So this is it. This is the final night in terms of presenting new content. After tonight, everything that Professor Eyrich has asked me to prepare will have been presented. There is one more day on Thursday. The topic for Thursday is kind of open at this point. Again, if people have specific things in mind they'd like me to present, feel free to write me an email or speak your mind now. The other thing I should say is it's also totally cool to just do an hour or two of demos, questions that have come up over the past week and a half that you guys would like to see actually just sort of gone over in a little bit more detail. We're totally welcome to do that for an hour or two. And Megan wants to say that it will be catered. There will be pizza and beer Thursday. She wanted me to get a show of hands. With this sort of free format, who would be interested in showing up Thursday night? Okay, most of you. Awesome. Cool. Okay, so if you have questions, bring your questions. If you have ideas for a more formal thing that you would want me to show, please send me an email. If there are things that you would want to show, like if you've developed Python code over the past week and you want to come up and talk about it, Megan wanted me to specifically make that an option. I think that's a great idea. And you guys are welcome to do that if you want to prepare something like over the next 36 hours or something. Okay, otherwise, so tonight we're going to be talking about APIs and web scraping. Initially, with this first survey that went out, I asked everybody what sort of APIs you'd want to see. Thank you all for giving me feedback on that. For the handful of you that requested Amazon Web Services stuff, I don't have access to a ton of that stuff, so I can't really present that. I don't have a cloud computing account, which makes it very difficult to show you Bodo, but know that there's lots of Python packages for doing automated calls to AWS if you want to set up a whole bunch of stuff that'll automatically do cloud computing stuff. What we will be going through tonight is Facebook, Twitter, and Reddit, the sort of big three of social media. Another option for Thursday is if you guys want, if there's some other API that you would want to be demonstrated, we can quickly do that. So if you have something else in mind, please let me know. To get started, first things first, we're just going to go through installs as per usual. The only one that's actually kind of complicated and annoying to install is just the Facebook SDK. It's the Python package that we'll be using. I'm getting some heads that are suggesting that this actually wasn't so difficult to install, but with these steps, you should be able to just run through, quickly install everything you need to do in order to actually get the Facebook package working in Python. So to do that, if you haven't already installed Git, you could just do conda install Git right now. And that should take about a second or two to run. And then from here, we're running pip install, and we're actually just downloading the most recent version of the Facebook API program from the GitHub page. We are changing the directory in the terminal directly into this folder of this software that we just downloaded. We're running the install script with Python setup install, and then that should be it. It should be installed in your Anaconda distribution. You should be able to run everything. And you can delete the original source file. So when you make this download, it'll download everything into a source file that you can delete. Otherwise, we'll be doing a few other packages tonight. We'll be going over the request package, Twython for making Twitter API calls, praw for Reddit, and Beautiful Soup 4 for doing HTML parsing, the aptly named Beautiful Soup. If everybody can run all these things, they're not running into trouble, great. Hopefully nobody's running into trouble. Okay, we'll get started. So I'm hoping tonight, again, will be pretty quick. There will be time at the end for demos or questions or anything that you guys want to cover. So I'm just going to run through this. Quick show of hands. How many of you guys have used an API before? Okay, a few of you. Okay, so basics here. A lot of companies nowadays are really great. They collect a ton of data from their users. They store it all in some mass database. They allow web developers and software developers and data scientists to just access that data through an API, which is the application program interface. Basically, they will come up with a very small programming language that will allow you to basically make search queries into that database to pull things out. One important distinction that needs to be made ahead of time is that you can register basically, whenever you're going to make an API call, whenever you're going to request data from that database, you need to have a unique ID and you need to have some unique password. I show you a few examples of how to sign up for these accounts, but importantly, there's two different types of accounts you can register for. There's user authenticated accounts and application authentication. If you were to do, like you were gonna try to develop a full mobile app, something that like people could use on their phones, you'd be doing a user authentication because you would have to have access to their specific Twitter accounts or their Facebook accounts or their Reddit accounts. If you just want publicly available data, things that you could access without signing up for Twitter or Facebook or Reddit, that would be an application authentication account. That's everything we're gonna be doing tonight. You don't have to pay for those. Oftentimes you don't actually have to have an account with that service to sign up. That's true for Twitter. Unfortunately, that's not true for Facebook, which is a real hassle for me because I quote unquote live off the grid, not actually though. And that's not true for Reddit. You need to have a Reddit account to actually make calls. But anyways, everything we're doing is just through the application authentication tonight. We're gonna start with with Facebook. It's really straightforward to register an app. You just need to go to developers.facebook.com. You do need to have a Facebook account. It's pretty easy to just go through and add a new app to your account. This is my girlfriend's Facebook, so thanks, Caroline. But it's really easy to, I'm just one of those assholes that isn't on Facebook. But it's actually really, really remarkably easy to just make a new app. You basically just need to give it whatever the app is, the app's name, some email. And once you get that, they're going to give you a unique ID, and they're going to give you an ID secret, which is basically your unique password, which you're going to need every time you're going to make a query to the Facebook database. Okay. Their database is stored in a quote-unquote graph structure in the sense that it's comprised of nodes, where nodes are basically all the content to Facebook, being users and pages and events and locations and so on and so forth. It's also comprised of edges, which is just all the relational data between that. So, you know, users 1 and 2 are connected. They have edges because they're both friends, or this comment is related to this photo because somebody posted a comment on that photo. And all of these things have different fields, which are just their attributes. So what the actual text of a comment was, or what the actual photo of a photo was. We're going to basically just go through the syntax of Facebook's query just to give you sort of a high-level picture before I actually show you the code. These are the specific nodes that you can search through Facebook. You can look through users and pages and events and groups and places and so on and so forth. Searching through this is remarkably easy. There's two things you actually need to specify when you're making a query to Facebook's database. You need to tell it what sort of information or type of information you're looking for, so a page or event or a user. You need to give it a search term. And then there's a bunch of options that you can do. So you can say, okay, I want to find all of the content before some date, or all the content that comes after a date. You can say, if you get an ID call from a previous search, you can basically say, give me all the content that comes after this previous call that I made or before this previous call that I made, which is really useful if you're beginning to data mine from Facebook, because you don't want to just duplicate all the data you collected. You want it to start at the end from a previous query. And that's really it. If you want the full documentation, Facebook is actually really, really nice. They've given you a huge, absurd amount of information, insane just pages and pages of tutorials for actually how to query everything. So I'm just going to show you a few basic examples, but know that there's like very meticulous, crazy meticulous notes through the Facebook developers page that we don't need to reiterate here. So if you were able to get the Facebook app installed, it's real easy to start using it. So the Facebook SDK module is just going to be importing Facebook. And here's what we're going to be doing. I sent around a Dropbox link earlier today. I'm giving you all access to my authentication keys. I would love for everybody to delete those keys once this class is over, but sure, you know, be nefarious. There are lots of different, they're just strings, right? So there's just text. They're like 30 characters that are randomly generated. You can store them however you want to store them. I typically store them in a compressed NumPy array file because most people don't know how to open those, which means that they're slightly more secure. All we're doing here is I'm just loading in my Facebook authentication keys. When I do that, so I'm going to get this new instance, OAuth. OAuth is just a NumPy compress file. Remember that NumPy compress files are like dictionaries in Python. So I've got two keys here. I've got my unique identifier and my secret code. I'll pull them out because I can index into them just like Python dictionaries. So here it is. This is my unique identifier, and that's my secret code that I'm going to need in order to make a call. That's all that's happening there. Basically, when you're first getting started, we're going to, again, initialize a new instance of basically a Facebook query object. So I'm taking my Facebook module, I'm saying, okay, initialize a new instance of the Graph API, and I'm specifying version 2.9. Every few months, Facebook will freeze a copy of its data in a new version. It's basically just a fixed set of data that you can query through. Version 2.9 is the most recent freeze. It's the most recent data dump of that. They update it meticulously, but a lot of it stays frozen. It means that, for example, you can't get Facebook data from 5 years ago, but you can get Facebook data from the past 2 years or 18 months. So again, we're initializing a new Facebook object, and I'm specifying which version. Once I have this new object, I'm passing in my app ID and my app secret, and I get a one-time use app token. And I'm just going to reinitialize that call with my new access token. What's happening with the access token is basically just checking and seeing whether or not I'm doing a user authentication or an application authentication. Given that my unique ID corresponds to an application authentication, my access token should be purely making calls only for publicly available data, not for user-specific data. So I can't get anybody's messages to different users, but I can see who's posted on what pages now. Okay. So once I call that, I get a new Facebook Graph API object, and now that's it. Now we're ready to start making queries. So up above, I showed you that we can query different types of things. We can query events and users and pages and so on and so forth. Here, I'm going to do a very hackneyed search. I'm going to search for all the pages on Facebook that match the search terms Python, because I'm sure you guys could see that coming. And I'm just going to limit it because we have some options on how we want to do that searching, right? So I'm going to do the limit field, and I'm just going to say, give me the first 5 results. So it looks a little strange, but what I get out is a dictionary. So when I made this search call, I stored in results a new Python dictionary that has 2 keys, my data keys and my paging keys. We'll go through paging first. Paging is really straightforward, actually. All it basically gives me is just some URLs and some identifiers so that if I wanted to iteratively make these calls, I could do a new search query specifying after or before, one of the two, which would basically say, okay, now give me the next set of results that came after this unique identifier or before this unique identifier, or came next in the list of search queries based off of this URL. That's this metadata that's stored in paging. That's going to be really, really helpful if you want to make basically a crawler, or just one large for loop that will just go through and just store, content page after page after page of search results from Facebook. In data, basically we just got the results of our search. It's just a list of dictionaries where we have the unique ID for each page that was returned and the name of that page, and that's it. If we want to look up more information about those pages, we're going to use a new function call. We're going to use this getObject function call from the graph. There's 2 things that you're going to specify here. You're going to specify the ID of whatever it is you're trying to look up. So here, what we're going to do is just look up the first page from our Python search query. So we're going to look up just some information related to the Python developers page. So I get that, because remember, results data stores all of my search data. If I take that first element of it, which is what I'm doing up here, I'm just getting the unique dictionary that stores the information here, and I'm just extracting from that the ID so that I can do a new search query. So that's what I've stored in page ID right here. I'm specifying there, so I'm going to search it, and I'm giving it some new fields. Remember, fields are all the attributes that you can look for. There is an insane amount of documentation about which objects have which fields. Facebook has it all documented here, specifying which attributes pages have and which attributes users have and which attributes comments have, so on and so forth. Just to keep it simple, when we're going to do a new query on this Facebook page, we're just going to look up its unique ID. We're going to look at the name of the page, the about of the page, and the URL for the page. And I'm just getting all that from this getObject call. And great. So I can actually save all my search information into this new variable metadata, and I get out things like the page name, it's Python developers, and its unique ID, and its URL, and its page description. Once we have its page ID, we can actually do even more things. So before, we use getObject. GetObject is going to return information, like sort of metadata about the object, but we can also use the getConnections call to store or to collect all the relational data. Relational data for pages are oftentimes just going to be posts. So what are the moderators of that page actually posting to the page? And you can see that's exactly what I'm searching for here. So I'm specifying the page ID, I'm specifying what information I want to get out of it, and I'm just giving a limit of 3. And just as a default, we get out the 3 most recent posts that the moderators of the page made to the page. We get its creation date, we get its unique ID, and we get the story. If we wanted to, we could collect even more information, like what was the body of that text, were there any URLs submitted to it, were there any photos associated with it. But you can see it's pretty easy syntax, and it's just returning really basic Python data structures. There's nothing complicated going on here. This is just a list of dictionaries where each dictionary has the same identical setup. They all have the same fields. And one really nice thing about this is that if you remember back to last Tuesday, so a week ago, I said one really nice thing about series from the pandas library is that series can accept dictionaries. So that's actually great because we can basically pass these dictionaries that we're getting out into into pandas series, and then we can take all the series that we make and immediately put them into one data frame. So it's really easy to make all this data pretty very quickly. So that's exactly what I'm doing right here. So for every post that I got out from my query up above, I'm just passing that into a series, and then I'm passing my list of series into the data frame, which means that I can very quickly just make this into a new pandas data frame object, which means that we can immediately save all this data out into a CSV or a tab separated file. So this is 5 lines of code, and you can imagine just doing this in one long for loop that just immediately makes a query, stores where it left off so that it can make a new query, takes all the search results from that first query, stores it all into a data frame, and dumps it or just stores it in memory. And then just basically, as you make new queries, just keep appending to that data frame over and over and over again. And once you're done, for example, collecting all of the posts over a month, saving that to file, and then you have it for use later. And in fact, that is what we do right here in this very simple script. In fact, all the code here is basically exactly what I showed you before. I can update that to 2.9. So I'm just making a new Facebook object by giving it my authentication keys. I'm just going to search, for example, Barack Obama's page, and I'm going to just look for all of the posts that Barack Obama's, or the moderators of Barack Obama's page has made over the past few months, and I'm going to store all the comments that I've posted to that. And I filtered it so that they're not disgusting. But you can see, very quick for loop that basically just makes all the same calls that we did before. So we use getConnections, for example, to get all the posts to this page. And then once we did that, I could extract from each post using each post's unique ID. I can make a new getConnections call and extract out all the comments that were made to that post. And I can store them all together into one data frame. And that gives me when the comments were made, the unique ID of those comments, how many times it was liked, and what the message of that comment was. And we get that all out for free right here when we make this get connections call. So I'm specifying the post ID, I'm getting out the comments from that post, and I'm specifying what fields I want out. So the ID, when it was posted, the message of it, and how many times it was liked. Does that make sense to everybody? Were there any questions on that? So it's actually pretty straightforward syntax. Things get more complicated, for example, when you are, there's lots of different ways you can do this for an application use, right? You can imagine doing just a sort of massive backlog of collection of posts, and you could go back and collect all of the comments posted on a page over the past 3 years or something, and you could store them all into one pandas file and then save them all into a tab separated file, and that would be done. You could also imagine a more complicated case where you have a script that automatically runs once a day to collect all the new content to few pages, in which case you might need to put a little extra thought into how you want all of this data to be stored in the long run, whether or not you want to have a new tab separated file for every day, or whether or not you want to actually just have it constantly appending to a previously made file, so on and so forth. But the really important thing in terms of just being aware of is that the Facebook API is really nice. It gives you all this metadata out. So as long as you store where you left your previous search at, it's really easy to start from that previous search. So once you have this metadata, so for example, these cursors, the after, before, or this next, you can use any of that information to basically say, okay, keep searching for everything that was posted after this last post or before this most recent post or something like that. So again, not a ton of code. You can make a nice for loop that you can run and you can collect through things. So this morning, actually, I'm starting up a Reddit project, and with a similar for loop, was able to collect like 50,000 posts in about 20 minutes. So it's pretty nice. The other nice thing I should say is that maybe some of you guys might be aware of the rate throttling problem, which is that if you try making too many calls to Facebook's API at once, they will ban you because they don't like the fact that you're making thousands of calls in the split second. One really nice thing about that Facebook SDK app or package is that it will rate limit for you, so you don't have to worry too much about it. Like I wouldn't try to break it and then try to make like 10,000 calls at once by like doing some weird parallel computing thing. But if you just use their objects, it will slow you down if you're making repeated calls. So you don't have to worry about like whether or not Facebook will ban you. I learned that the hard way when I got banned from Google Scholar for 2 weeks. So be careful. So there's not an official Google Scholar API because Google in general actually doesn't want you data mining any of their stuff. Somebody wrote an excellent package in Python for crawling Google Scholar, which is really nice if you're trying to do like citation trees and citation webs. I messed up because that package does not have a built-in rate limit. So I made many thousands of calls in a second, and then they did not like me for a while. I also did it at work, which was even worse. So don't do that. Be smart, don't be Sam. So that's Facebook's package. It's remarkably simple. For loops are really easy. The syntax is super straightforward. You just got to think of a problem of what sort of content do you actually want to mine, what's actually interesting to you. I can't speak a ton for Facebook because Facebook doesn't seem super interesting to me, but I'm sure it is. Twitter is basically the same setup as Facebook. We are just going to be using a different Python package, of course, but more importantly, Twitter's API is awesome because, just to start really fast, their function call, their search query is basically the same exact thing. The only thing that's required is you just need to give it some search term for what you want to search over in terms of tweets. It's basically the same otherwise setup where you could basically say, okay, search for all tweets that came after this date, or search for all the tweets that came before this date, or search all tweets that came after this ID based off of a previous query I made. It's the same exact setup as Facebook. There's a ton of documentation that Twitter has written in terms of how to set this up and how to do it appropriately. Twitter has a really awesome query syntax though, much better than Facebook's now that Facebook actually deprecated their, they used to have a mini language, but they got rid of it. Twitter's search syntax is really, really cool, and I just want to highlight a few of these things. Obviously, you can do the really basic operations, like you can search for 2 words and it'll look for tweets that have both words in it, and if you put them in quotation marks, just like Google's search, like it'll search for that specific phrase. They have a lot of really nice conditional stuff. So for example, you can do love or hate. So things that contain either love or hate, but not both. You can look for, let's say you want to find all tweets about beer, but not tweets about root beer. You can put this negation symbol, and it'll basically say, okay, give me all the tweets that contain beer, but don't give me any tweets that contain root in it. You can search, obviously, specifically for hashtags. You can search specifically tweets from a given account or that were directed to an account. You can filter tweets by what media they might be linking to, whether it's a video or a photo or something. You can actually say, you can filter out all retweets, which is really nice. You can search for specific links. You can actually look and see whether or not people are linking to specific websites. So if you did URL : Amazon, you could actually look for all tweets that were specifically making references to any URL that was directed to Amazon. And perhaps kind of the coolest thing is that Twitter has a built-in, I guess they're doing some nice sentiment analysis in the back end. If you specify this very cute looking positive emoticon or sad emoticon, they will return tweets that have higher positive language or higher negative language. I guess they're doing automatic sentiment analysis of all of our tweets in the back end, which is absolutely terrifying, but is really nice if you want to do sentiment analysis about tweets on Twitter. So just be aware of that. Oh, and you can also do this question mark thing to find people who are specifically posting questions to Twitter, which is also really neat. Twitter's API is really, really cool. I was playing around with it earlier, and it's really cool how selective you can be. Twython is the package we're going to be using. It's really straightforward. The only, I guess, slightly more complicated thing about it is that they want all the search queries that you make to Twitter need to be URL encoded, which is really, really straightforward. Basically, all this means is that everything needs to have hyphens or underscores in it, just in the same way that you would see it in a URL up top. And it automatically converts certain characters into certain other things. So like, parentheses get changed into %28. There's a Python library that will do that for you automatically, so you don't need to write your own dictionary, you don't need to remember any of those conversions. Twython works in the same way as the Facebook SDK package. We're going to do the same exact set of steps to initialize a new Twython instance, which we're going to use for querying Twitter's database. Again, we're just going to load in the authentication keys, we're going to pass them in, we're going to get an access token, and then we're going to reinitialize with our access token. Because we are doing we're doing an application authentication. Again, this is not user authentication. So you won't be able to search anybody's DMs, but you will be able to search everybody's public tweets. So again, more hackneyed or trite examples. Let's search for positive tweets for people who have specified the hashtag Python. So what's happening here? We defined a query. We passed it through URLlib to actually just make sure that it was properly HTML encoded or URL encoded, so you get this weird looking thing. And we just used the .search attribute of our new Twitter instance to pass the query, and I just specified that I only wanted English tweets, because that's what I read, because I am monolinguic. And what do we get out? We get out this new dictionary of results that is, again, just as before, it's another dictionary, but it's got a ton of stuff in it. In fact, you get a lot of things. It's really easy to break down. This dictionary that's returned in results gives you statuses and search metadata. Search metadata is, again, just like Facebook SDK, same exact thing. Basically, it's going to return to you some important information about your search, like how fast was it completed, and how many results did you get. but more importantly, it gave you the max ID, which was the final tweet of your query. If you add +1 to that ID, that's where you would start off in your next search query. Or you can use the next results, and that's where you would start when you would make a new query. That way you're not getting duplicate tweets. Every time you make a query, you're starting from where you left off. You also get statuses, which is a ton of information about all of the tweets that were returned from this query. I'm not going to make you read that because there's a ton there. It's broken down a little bit. So for example, you'll get things like the tweet ID and when the tweet was tweeted and what was the text of the tweet and how many times was it retweeted and how many times was it favorited. And if somebody's got geocaching on or geocoding on, you can find out from where they tweeted it, which is super creepy. You can also obviously get their user information and some metadata about the tweet, and how many times it was retweeted and all these things. Because again, just like before, statuses is just to make it very clear, statuses is just a list of dictionaries, same as before. Again, which means that we can just pass each individual dictionary in our list to a series, make it a pandas series, and then pass all of those series as a list to a data frame, and then just convert everything into a pandas data frame so that we can... Oh, did I not search you? Why'd you do this? Why'd you do this to me? Have you ever just had that moment where it worked 20 minutes ago and now it's not working and you have no explanation for why it's not working? It's the best. Oh, okay, let's get rid of that. Great. So apparently that thing was no longer a thing. Cool. Anyways, it's really easy to dump all this out, and it now becomes substantially easier to read because all of those fields were now turned into columns, and at least it's a lot more human readable now, and we can store all this, we can drop the columns that we don't want, we can keep all the columns that we do want. Basically, if you follow through on the pandas tutorial, now you can Twitter mine easily and just dump everything out.
What did you cut to get that to run?
I just commented out the df.drop because apparently one of the columns no longer exists because they weren't returned as metadata for the tweets that we searched, which is the fun of working with APIs, is that you will spend a lot of time making your code robust because oftentimes it is the case that certain tweets have metadata that you want, but not every tweet has that same metadata. So if your code is always looking for that metadata and doesn't have the right try-catch exceptions, then your code will error out frequently. Again, be a better coder than Sam. Let this be a lesson. It's really nice now, once everything's as a data frame, right? We can just do the same sort of indexing and just get out all the text of all the tweets that we just searched remarkably fast and easy, right? Because it's just a pandas data frame again. We can also do some interesting information to restrict out some of the metadata. What's happening in there? Oh, there's swearing in there. Naughty, naughty, Twitter. There's some embedded dictionaries within the dictionaries. So for example, if I took out this first dictionary and then searched entities, you'll see that there's a dictionary in the dictionary. So the entities field of the first tweet contains another dictionary that contains a lot of metadata about that content of that tweet. I'm just pointing that out because pandas can handle that. So if you look in here, pandas in the entities column is now storing entire Pythonic dictionaries. Pandas can do that. Panda can handle that. If you try to save that to a file, then reopen it, things will get really messy. So just be aware that you might need to write some code, which is what this line of code is doing right here, that will pull out dictionaries and make new columns or get rid of that stuff or pull out the relevant information from those dictionaries so that you don't end up with columns of dictionaries. Just be aware that Twitter's a little funky. Okay. And just as before, we'll just do a very quick just one long script that's just doing the same exact thing. So we're doing authentication. This time I'm searching from all the tweets from the official Columbia account, because why not? We're getting rid of the retweet, all the retweets, and basically it'll take a second, because again, Twython is really great. It'll do rate limiting for you so that you don't get kicked off the Twitter API, but it'll take a second. Oh, I actually put a sleep timer in there. Ooh, let me actually give that as an example. If you're worried about whether or not your code is going to obey rate limiting and you don't want to get banned, there is an entire other module that you can use in Python called time. And time is really nice. It does a whole lot of things, like you convert time between all different time zones and different machine readable times and things like that. But there's also this nice little function in there, which is time.sleep, which actually just makes a call to the OS, and it just basically freezes your script for however many seconds. So if you wanted to manually make sure that you were obeying rate limits, and the rate limit for Twitter, I think, is actually low. It's limited to making one request every 2 seconds. It's actually fairly low. Facebook will let you do thousands. So you can see I just put it in. I put a manual sleep timer in there so that I was only making one loop of that for loop once every 2 seconds, so that I was explicitly obeying their calls. But yeah, so now we get out, a new pandas data frame that has all of these tweets from Columbia. Let's talk about Reddit real fast. How many of you actually use Reddit?
Define use.
What?
Define use.
How many of you are aware of just what Reddit is? Okay, that's better. Yeah, I also don't use Reddit, but I like mining its content. Reddit is kind of annoying. Similar to Facebook, you actually have to register for a Reddit account in order to use it. That's not true for Twitter. You don't have to have a Twitter account to data mine their API. We're going to use the praw, or the praw, I don't know how you would pronounce that, package in Python. It's, again, remarkably easy. In this initial lines of code, we're just doing the same exact things we did before. We're just initializing a new Reddit instance, which is going to allow us to make calls. We're just passing in our client ID, our client secret, and our user agent. And all of that is given to you if you register for if you just register for an app through Reddit. It's really, really easy. So I'm actually doing some stuff right now where I'm trying to look at symptom clusters, whether or not you can predict how different psychiatric comorbidities will exist in individuals based off of how they post on Reddit. The most important thing, I'm going to go through this really quickly because it looks like most of you guys are familiar with Reddit. You're aware that Reddit is just a giant forum. There's a bunch of subreddits, which are subforums, particular specific topics. People make submissions into those subreddits, and people comment on those submissions. If you get that hierarchical structure, you're ready to search through Reddit. And that's because praw basically works in that sort of descending hierarchy. You search through subreddits through praw, then you'll get a list of submissions, all of which are queryable, and from those submissions you'll get comment data and you'll get user data, all of which are queryable. So it's just really easy to basically write these sort of nested for loops where you're going to search across a subreddit, and then you'll search across all the submissions to that subreddit, and then search across all the comments on that submission in that subreddit, so on and so forth. It's really easy now that we've run this first line of code. We can look at all of the subreddits that concern avocados. There are many. I don't know why. And it's also kind of nice is that if you're not familiar with Reddit, there's also like a random subreddit, and there's also other functions that praw has to, for example, they'll refer to you to like the default subreddits, so like the 20 or 30 most popular subreddits on the site. You could search by all sorts of different ways to identify what subreddits might be of interest to you. The important thing here is that once you get a subreddit out, so I'm going to look at random subreddit, which was submitted. Avocados are hilarious. Every search instance that you get out becomes its own instance. So if I search for a subreddit, I get a subreddit instance out. Once I get a subreddit instance, I can look through all of these attributes of that subreddit. So I can look through all the comments. I can look through the moderators. I can look through all of these things. Some of these things won't work for you because Reddit's API, a lot of it's actually geared towards writing apps that users can use to do automatic posting. Again, we're doing application authentication, not user authentication, so I can't use this code to make automatic upvotes or downvotes or automatic sending messages to users because we're not registered as a user right now, we're registered as an app. So a lot of these things won't work, so I can't like send a mod mail or anything like that. But I can get the rules out for this subreddit. Once you have a subreddit of interest, so we're going to look through the Learn Python subreddit, it's really easy to make queries. So the .submissions attribute of a subreddit is what you're going to use to go through and make calls and look up or query all the submissions to that subreddit. You can specify start and end dates. So this is just some fancy code right here that's converting these dates of interest into Unix time, which is a machine readable date format. So if I run that, start went from looking like 2017 June to just this long float, which is just the machine readable date. But this is really nice because now basically it's even easier to just search through. So I could write a script and I could just run it once a day and basically say, give me all of the content that was posted to the subreddit between today and yesterday. And that's perfect because then you can just basically run it once a day and just take all the content out. Just like before, when we searched for subreddits, we got a subreddit instance. When you search for submissions, you'll get a submissions instance. Initially, submissions are just a list of submissions, but you can see these are all of these instances. So these are all individual submissions that have been made to that subreddit. You can search through them to find interesting things. So for example, we can look up the author of that submission, the title of that submission, the score, and what the actual text was. So ironically, we data mined somebody who's trying to data mine Twitter. Haha, take that. From a submission, you can also look up all the comments. And again, when we take out the comments, that'll just give us a list of comments. So I took out the first 5 here. The default is just return the first 5 of anything, but you can switch that out. Once we get the comments, we can also look up the same sorts of things. So I can look up the author, I can look up the score, I can look at the body. So again, data mining, people who are talking about data mining. That's basically how PRAW really works. It's got a series of classes that are just based off of the common, sort of the core nodes of Reddit. So there's a subreddit instance, there's a user instance, there's a submission instance, there's a comment instance, each of which has its own important attributes, like what was posted, how many upvotes or downvotes does it have, so on and so forth. And it's really just working through each of those instances and pulling out the relevant information that you would want. Again, same sort of for loop as before. We are just giving it authentication. I'm defining what date I want to go through, so give me all the submissions from this date. And this for loop right here is just going to pull out some information about all the submissions that were posted between these days and all the comments that were posted to that submission, just doing the same sort of pandas thing that we did before. And PRAW, again, will do the same sort of rate limiting for you, which is why it's taking a second. Because Twitter's is rate limit of 60 requests a minute or 1 a second, so it takes some time. This is sort of strange, but again, going back to some projects that I'm working on, so this is actually kind of sad, but it's pulling out posts from subreddit that is all about giving support to people with anxiety, which is much more relevant to the sort of work that I do in my everyday life. Psychiatry, in it a hoot. Those are 3 really basic APIs. I should say that obviously Twitter, Facebook, Reddit, really popular social media, they're are obviously way more databases in the world to mine than that. There is a huge, huge list of that somebody put together. Huge list of most, I'd say probably 80% of the currently available API wrappers that are written in Python. There is a ton out there. So if you don't want to have to write web scraper code that will go through and scrape a database for you, people have done this for you for a lot of really popular things. Things that are not included on this list that I found in my own time were things like the Federal Election Committee, if you want to see what politicians are getting what subsidies from which people and which kickbacks, because we're living in a graph society. You can do that. You can look up, as we talked about before, you can look up things like Google Scholar and Elsevier. If you want to do like citation trees and citation webs and look at like who's collaborating with who in science. IMDb's got its own really cool API if you want to look at like what are the factors that contribute to positive or negative ratings of movies. And actually Last.fm, which is a website nobody uses anymore, but is what I first started doing, how I got into APIs in the first place, if you're interested in looking at how people categorize music. Tons of API content out there. We're going to do a really, really brief overview of web scraping. 7:50. If you guys just want to plow through, this will probably take 10 minutes. Let's do it. There are two really, really important packages in Python right now for web scraping. There is Beautiful Soup, which we'll talk a little bit about tonight, and there's Scrapy. They are not competing, but complementary packages. They do different things. Scrapy is really, really cool. I was not aware of it before this course. It's coming up. They have really, really good documentation and really good tutorials. Basically, it's an entire library that's just built to doing really, really fast automatic web scraping, where you can give it 1,000 web pages you would want to do, or better yet, you can start it on one page and then it'll automatically start traversing to other pages, whether or not, like, for example, that page is a list, it'll just automatically traverse through that list for you so that you don't actually have to specify those URLs. It's a really awesome library that I'm not super familiar with, so that I don't feel super comfortable doing, but playing around with it, I could get like 1,000 web pages in like seconds. It's super fast and just spits out everything into really easily mineable content. The other thing that we'll be talking about, which we will give an example of, is Beautiful Soup, which is a really great package for HTML parsing. Obviously, HTML is one of the main languages that everything on the web, it's what it's written in. It's a real nightmare to have to traverse. Beautiful Soup is a really cool library for being able to effectively and efficiently traversing through HTML. So I'll give you just a brief example. What we're going to be doing in 10 minutes is we are going to go through the website album of the year, and specifically, we are going to go through this table. They are kind of cool. They put out basically music reviews, and they put together this huge table of all of the ratings of every album that has come out this year. So let's say we wanted to mine this, because you're like me, and you're stuck listening to the same things that you've been listening to since 2012, and you really need to like get with the times, man. So it's actually really easy to do this. We're going to be using two packages. We're going to use requests. Requests is just a very quick and easy package that will actually just make a call to a website and extract the HTML. And we're going to be using Beautiful Soup, which is going to be parsing that HTML. So I'm just going to specify manually the URL that we were just at. So it's the same URL. I'm going to use the request package to get the HTML from that URL. And I'm then going to pass it to a new Beautiful Soup instance. We're going to store that instance as soup. And the soup is basically just going to be the weird goo and muck that is HTML when you're parsing it. To show you what it looks like, we're going to use the prettify function from Beautiful Soup. It prints out basically the nice indentations of how HTML is actually written. This is what HTML looks like if you've never worked with HTML. It's kind of a real pain. Everything's encoded in brackets. Everything has tags. Those tags specify different functions, like where everything should be indented, or whether or not it should be linked to a hyperlink, or whether or not it's a header, or what color the font should be. And it looks like this. Prettify is super nice because if you don't use that, you can get all the text out, and it just looks like this. It's just one long string of gobbledygook, and it's not parsable, and it makes your eyes bleed. So soup.prettify is great because it at least gives you an intuition for what the HTML actually looks like. To give you a brief, and how many of you are actually familiar with HTML and have worked with HTML? Oh, great. Okay, I don't need to explain a ton then. Obviously in HTML you have different tags. Tags are code for different things. Tags have different functions for a website. It's really easy once you have a soup instance to get through and parse through different content. So firstly, you can actually just search for tags just using the attributes. So if I wanted all the A tags out, or actually this will just return the first A tag, but I can get the first A tag, I can get the first break tag, I can search specifically by tag, or I can use this find all function that will return every instance of a given tag in the HTML document. So I can get the first 5 A tags, for example. Tags become their own instances with their own attributes that you can extract out all this important metadata from. So I took the last tag from it, and I could get things like the hyperlink. I could get, for example, the contents of it. I could get other things. You guys are probably actually more familiar with HTML than I am, but the point is that when you use find all, you'll get a list of tags out. Those tags, just like before, were like searching through a subreddit gave you submissions, and submissions are their own instances. They're their own class objects that have their own attributes and functions. So too here, when you make a new soup object, you can search through tags. Tags have their own attributes that you can use to search through. One really nice thing that it has is this descendant attribute. If you give it a starting tag and you give it the descendant function, it'll just parse through everything that is beneath it or indented in it, which is actually really perfect here because it turns out that the tag that was encoding all this information was the TR tag. So I can use find all to return all the TR tags, and then I can use the descendant to just parse through all of the metadata or all the information that's stored under that tag, which actually just turns out, in this case, to be all of the strings encoding all of these ratings. So if that doesn't make sense, let me show you what this actually looks like. So we pull it out, and I'm just printing out each individual row after we parse through each individual tag, and you'll see now it becomes much more sensical. So we get the first line of the table, right? And then the next one is all the individual ratings. We can get all the album information out. And just like before, we can take all of this and just very quickly store it into a data frame. So what I did there is I took each individual row, I stored that into a list of lists, and I just took out the first row, which gave me all my column names, and I just specified that as my columns in my data frame. And then suddenly, that was it. With very little code, we were actually able to reproduce this entire table. And let's say that you are definitely like me and you really haven't paid attention to anything in the past 5 years. That's not entirely true, but for why not? Let's say you wanted to recreate this table across the past 5 years, or from 2013 to 2017. Now we can just create a for loop that will iteratively extract the HTML from each of those websites from 2017 and 5 years back, take all this code, parse through all the TR tags, search through with the descendants option to basically extract out all the information that's stored in those tags, place them all into a data frame, and make it nice and pretty. I'll take a second. And then very quickly, we can look at all the top-rated albums that have come out in the past 5 years. I agree with some of these. So yeah, it's actually pretty easy to do this. So Beautiful Soup makes it really, really easy. You have to sort of invest the time a little bit to look through and actually understand what the structure of the HTML was so that you know what information you actually want to get out of it, and that becomes sort of a weird deductive logic problem where you're like, okay, as I just parse through iteratively through these tags, it actually appears that all the content that I want is associated with this tag. Thus, I'm going to write a for loop that just extracts out all that stuff. But again, the repeated theme throughout this entire sort of very brief tutorial today is that you can write a very quick and easy for loop that makes calls either directly to the HTML or to an API. And if you can just extract that out into either a list or into dictionaries, it's very quick and easy to store that into a data frame. Once this is a data frame, it's very easy to do any of the sorts of methods that we've been talking about for the past week. And it's also incredibly easy to just dump that to file so that you have it saved, and then you can do any of the text mining that you want to do with it, like we covered yesterday. Or you can do any machine learning stuff, as we covered last Thursday. So to really bring it all home, it all really just comes down to having some core familiarity with NumPy and some core familiarity with pandas with Python. Once you have those things, data science and analysis in Python becomes really easy and really straightforward. With that brief series of tutorials, that's what I've got prepared for today. And that's because API calls are really sort of just specific to your need. And same goes with HTML stuff, is that it really, the intricacies of it really come down to what it is that you're actually mining, right? So just needing to learn the search syntax for Twitter versus Facebook versus Reddit versus needing to learn how the HTML is actually structured for whatever website it is that you're scraping. Otherwise, that's really it. It is 8 o'clock. I can do more demos. If there are questions, we can go through questions. You guys have been great, and I've monopolized a bunch of your time over the past week as well. So we can also end early. Are there any questions about what we went over today? Does anybody have any ideas of how they would actually, things that they would actually want to do? Any project ideas that involve using an API or web scraping? I'd love to hear an idea. Yeah?
So if you like download like a CSV format or actual raw data, is there any way that you can directly link to like cloud services, Amazon?
Yes. So obviously you're familiar with Amazon Web Services. You can do all sorts of lovely cloud computing. Bodo is the weirdly named API service in Python for making calls to Amazon Web Services. I've never used it, so I don't feel super comfortable teaching it, but there's really extensive documentation. So, for example, one thing that you could do is you could leverage Twython or Facebook SDK and Bodo, and what you could do is you can pull all this information off and then directly throw it onto the cloud for storage or for analysis or whatever you want to do. So you can actually set all this up into one script. There's also, if you want to host a local server rather than using Amazon or some other web service, there is also direct, there are SQL packages in Python that you can just make direct SQL calls. So another thing that you could do is just directly pull individual tweets or whatever off and then immediately throw it into a SQL database or an SQL database so that you can store everything that you've mined. So if you don't want to just store everything in raw text or into CSVs or tab separated files, there's a lot of additional services you can use to either throw it up onto the cloud or throw it onto a local server. And throwing it onto a local server is how is what I did years and years ago when a PhD student and I were working on mining Last.fm data to understand how people copy each other and do interesting cognitive things when they're trying to categorize music. So we would actually scrape everything using the Last.fm API and would use PySQL or PySQL to directly throw all that into a server so that we could do querying later. And what we actually did there, which was kind of cool, was that you could do things like cron. I think, actually, don't know. Cron is normally a Unix thing, but yeah, there's a Python version of it too. Cron is a really nice package that is basically like a daily run a script function. You can basically set it so that it's like a daily alarm that like when you go to bed at 1 a.m., it'll just run the script for you automatically once a day or twice a day or 3 times a day, however many times you want. So for example, you could write a web scraping script or an API calling script, and then throw it as a cron job so that it'll call the script and it'll pull all of the content that you're interested in for that day. So it'll pull all the comments and submissions that were posted to a subreddit for that day. And it'll just do that for you once a day automatically. And then over the course of a few months, right, you'll be able to get all this content, and you can throw in all the previous stuff that we're talking about in terms of scripting to make it store onto server or store to cloud.
Can you do that? But what I'm looking for is the Federal Reserve puts their policy statements online, but they be their HTML links or PDF links on one page. So could you do what you just said, but tell it to go into certain files like on a page?
Yeah, so you could do, so it stores everything as HTML links to the, so I mean, one thing that you could do, which is perhaps not as elegant, but one thing that you could do, right, is just actually, I mean, the simplest thing you could do is just copy all those links. Do they update those links every day or something?
Every 6 weeks.
Every 6 weeks. So yes, you can make a cron job that, for example, called Beautiful Soup to parse that page and just extract out all of the HTML, or all the links, all the hyperlinks, and store it into some database and just check to make sure you're not adding duplicates, right? And then be done with it. Or if they search it with dates or something like that, just say like, take all the dates that are more recent than the last date that I searched through.
And if you just said it to do that at a certain time,
Mhm.
how long does Python take to do that? A couple seconds or a minute?
I mean, it depends on how much you're scraping, right? So if it's not a ton of data, it should be a few minutes at most. Like I said, so today I was able, as a sort of a test case, was able to get 50,000 submissions or comments from submissions in about 20 minutes. It's a pretty sizable amount of data that comes out pretty fast. Oftentimes, especially with working with APIs, the limitation is not the computation, the limitation is the business. So the limitation is how many calls Twitter or Facebook or whoever will let you make in a given minute.
Regarding that, I was wondering like how you can set up the limits for calls. Because like for Twitter or some APIs, they just offer automatically. When you're trying to create the API. But for example, you talked about Google Scholar, and I was wondering how you could stop by setting up some thresholds.
Yeah, so I mean, the absolute easiest way, there are certainly more elegant solutions to this. The absolute easiest way would just be to use just this, like I showed you before. You can just literally call the single line of code and put a sleep timer on every search, so that once it's done making a search query and it's done doing everything you're doing, just make it sleep for a few extra seconds. Now you can be really fancy about this. If you want to be ultra efficient, you can actually write code that will clock how long it took you to make that search query and do all this post-processing of your search query, and then subtract that from your sleep timer so that you're at the optimal efficiency, which is one thing. So to make sense of that, let's say that you can only make a call once every 2 seconds, and it takes you half a second to execute all of the code above the sleep timer, right? You could write some code in Python, of which there is a lot, where you could basically have the computer measure how long it took you to execute all of the lines of code up here, and let's say that took half a second, and then subtract that half a second from your default base setting of 2 seconds so that you're not wasting any time. There are more complex things that you can do. So I know like Scrapey and other packages have like pipelines where you can set default parameters where like how often do you want to make a call, and how many calls per second or how many calls per minute will you allow. But this is like a one-line solution that you can just embed in every for loop, and you can be as conservative or liberal as you want in terms of how much you're willing to risk in terms of cutting it, in terms of optimal efficiency of making queries. So the other thing I should say is if you're doing like one-time things as well, you could probably push it past, and the companies don't get usually too angry. But I wouldn't try your luck too much. But yeah.
Is there any possibility to scraping a web page that is to login, say by Gmail inbox?
Yeah, so the complication there is that for anything that is hidden behind an account, right, there are ways of specifying Okay, so the answer is twofold. If it's through an API and you want to get personal information, you just need to register for a user authentication account, right? So if you wanted to get all of the information out from like all of your messages from Reddit or from Twitter or something, you just need to register because they have the API and that information is available, but it's just hidden behind the fact that you're a given user. So when you set up those instances, you need to give them like your ID and your password and things like that. Requests, from what I understand, I haven't used it too much. Requests does allow, sorry, I'm finding it. Request does allow you to specify user ID and password. So if you wanted to, for example, specify a URL that is linked to a specific account, there are ways of doing that. I'm not super familiar with that because that's where you start moving more into the app development side. And I'm really much more familiar with just using open data, things that are freely available. But I know requests can do it, and I know there's a lot of documentation of doing app development and doing custom apps through Python. So I'm kind of flaking out on that answer a bit, but that's because I honestly don't know a ton. I know it's possible through requests, but I don't know a whole lot more than that. All these use cases here are really more from like the pure sort of data science side, where you're really just trying to use openly available data, and you're not trying to use anything that would require like users to give consent that you're actually taking that data. Does that make sense? Or additional consent beyond the terms of agreement, terms of services agreement that they're not reading anyways. Sad. Important to be responsible with all of this too, I should point out, is that you can get a ton of data out, and a lot of these things are really good in terms of making it really difficult to track back users. Like Reddit is really, really good in terms of making sure that only the slimmest amount of user information is actually available, so that you can't try to like really figure out who somebody is by going through their entire search history or through their entire post history. But like, be aware that some of these APIs you probably could use nefariously, and I'll say that I will not have it. I did not teach you to do that.
So let's say I want to display all the articles in a news website, and that website doesn't have an API. Should I collect all possible URLs out there, and how would I do that?
So that's a really good question. So it really, I mean, the answer really is, it comes down to what your specific use case is. Like, it really sort of comes down to what you're trying to do, right? Like, if you're mining content that has, I mean, if you're just trying to mine everything that's on the website, then you can probably use something like Scrapy that'll just take a base URL and then it'll just find all extensions of that URL, right? So like every possible filler in for the New York Times, it'll just iteratively add that on. And it'll just follow hyperlinks until it just traverses through and crawls through the entire web page. If you're going after specific content, for example, like you only want articles returned from a specific author, for example, it might be worth going, oftentimes a lot of these websites now will, if you search the author, it'll return a list of all of those authors' articles. It might be worth just taking that URL and then writing a specific crawler that will actually iteratively go through that specific list, just starting from something that you did online automatically, meaning that you use their online service to get that initial search result of all of the articles attributed to that author, and then start scraping from there. So the answer is, it really kind of comes down to what your problem is, or it sort of comes down to what your specific goal of analysis is. There's not a one-size-fits-all solution here.
This is more a general question. So in R, I've run into the problem with Bark Machine that it just kills your RAM really fast. So you have to put in a line of code so it doesn't eat up all your RAM. Have you ever come across that problem with Python where it eats up all your RAM?
I have, only in really severe cases where, for example, like if I'm doing neuroimaging data and I'm loading 10 gigabytes of brain images in.
But not stuff like this?
Well, so the cases where clearly I think you can run into issues, right, is that if you're storing everything in in the cache, and you're not dumping any of that information out. If you're writing a for loop and you're just letting it go, and you've now gone from collecting 50,000 posts to collecting 100 million posts, you might very quickly overwhelm memory just because you've collected an insane amount of data, right? So it might be worth embedding in those for loops that like after every 100 queries, or once my data table gets to 10,000 rows or something, like that's when you're gonna save it. This gets into a larger database management issue, which is how are you actually storing all this data? So, I mean, a lot of servers will handle this well, and it would be nice because then you can basically just, you don't have to actually store anything in memory, or you don't have to store a lot of memory, because you can do a query, pass all that to the server, and then delete all the contents of that, so that the Python instance itself is actually not storing a whole lot in cache. If you were going to store everything as text files, for example, if you weren't going to push everything to the cloud, if you're just going to store everything as text documents, then it might be worth embedding in a for loop like, I'm only going, once I hit 100,000 rows, save the file and be done with it. Or make it such that you just have a new file that corresponds to all the queries from a given day or from a given user. So for some Reddit stuff that I'm doing right now, I get all the submissions and all the comments that are posted by day. So I segment everything up by day, and I segment everything up by specific subreddit. And then in terms of users, I just have one file for that user. And sure, you'll generate thousands and thousands of files that way, but it's really easy to load all of that in. It's not hard to load anything in, but if you try to keep everything in memory all at once, that will be a problem. Pandas is also really nice. Pandas does have a lot of stuff where you can selectively read in, like for example, like the first 50,000 rows, do whatever processing you need to do, then read in the next 50,000 rows. Python also has a lot of stuff for doing that as well, with generator objects, which if people are interested, we could talk more about on Thursday. So if you're running up against memory issues, there's lots of ways that Python can handle that. It's database issues. It's kind of the bane of every big data scientist's life. Probably not. I'm sure there are better solutions for it now. I'm not actually a big data scientist whatsoever, so. Other questions? No? Okay. There were not exercises and solutions for this one, just because, again, it's whatever you want to do with this. I will reiterate, I'd love for everybody to delete my authentication keys from their computer. If not, feel free to do nefarious things. Sucks to suck for Sam. Otherwise, it's really, really easy to register these accounts. So if you want to play around with it, I really encourage, just go to Twitter, make a developer account. Go to Facebook, make a developer account. Check out this crazy long list of API stuff. I covered 3 things. There are, I mean, just hundreds and hundreds of pre-built APIs in there that cover tons and tons of topics. So economic data, political data, social data, cultural data, tons and tons of stuff. A lot of newspapers have APIs too. The New York Times has an API. Python has API wrapper for calling the New York Times if you're interested in doing stuff like that. And then a lot of, I think the New York Times even has articles dating back from like the 1800s. You can get really complete records. So yeah, go play around. Go collect some data. Go do cool things. Store them all in Jupyter Notebooks and then upload them to GitHub and show off how cool you guys are. Otherwise, Thursday, I guess, email me if you have specific topics you'd like to see. Bring questions. Otherwise, there will be pizza and beer. I hope to see everybody there. Otherwise, thank you all so much. We've covered all the formal content. And we'll do demos and hangouts, and I'll probably just show more pretty brain pictures on